Kubernetes and GKE Part 36. This episode has 2 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is Kuberbench? Here's a strong way to approach it. Kuberbench is an open-source security tool that checks whether a cluster running Kubernetes is configured according to security best practices defined in the CIS Kubernetes Benchmark core idea. Kuberbench audits your Kubernetes cluster configuration and tells you whether it is secure or not. It does not fix issues. It only checks compliance and reports gaps. Why Kuberbench is used? It helps you identify security misconfigurations, ensure compliance with CIS standards, improve cluster hardening, prepare for audits. SOC 2, ISO 27001, etc. Validate production readiness. What is CIS Benchmark? CIS, Center for Internet Security. Kubernetes Benchmark defines secure configuration rules for Kubernetes components, best practices for API server et scheduler controller manager. Kubelet. What Kuberbench checks? 1. Control plane security. API server flags et encryption scheduler configuration controller manager security settings. 2. Worker node security. Kubelet configuration file permissions authentication settings audit logs. 3. Policies and permissions RBAC configurations anonymous access checks insecure ports or flags. How Kuberbench works? Kuberbench reads node configs plus cluster settings, compares with CIS rules, generates reported, evaluates running Kubernetes components config files like or etc. or Kubernetes or API server flags system level settings. Example output info 1. Control plane security configuration fail 1.2. Ensure that the anonymous auth argument is set to false. Pass. 1.3. Ensure that the basic auth file argument is not set. Deployment modes. 1. On master or node, run directly on cluster nodes. 2. As a daemon set, runs Kuberbench across all nodes in cluster. 3. In CI or CD pipelines used for pre-production security checks. Kuberbench versus KubeHunter feature. KubeHunter type configuration audit security penetration testing focus compliance vulnerability discovery approach static checks active probing output pass or fail reports attack surface analysis. Simple analogy: think of Kubernetes cluster equals building, Kuberbench equals safety inspector checking if building follows fire safety rules and regulations. Benefits: helps enforce security standards, easy compliance reporting, identifies weak configurations, early works across cloud and on-prem clusters. Limitations: does not fix issues, automatically requires manual remediation, focuses only on CIS benchmarks, needs regular execution for continuous compliance. Best practices: run Kuberbench regularly, CI or CD or scheduled jobs, fix high-severity findings immediately, combine with runtime security tools, Falco, etc. Use alongside RBAC and pod security standards. Interview-ready definition: Kuberbench is an open-source security auditing tool that checks whether a Kubernetes cluster complies with CIS Kubernetes benchmark guidelines by analyzing control plane and node configurations and reporting misconfigurations to help improve cluster security posture. Nice. Let's continue. Question 2. Explain KubeHunter. Here's a strong way to approach it. KubeHunter is an open-source security tool that actively scans and tests a cluster running Kubernetes to discover security vulnerabilities by simulating real-world attacks. Core idea: KubeHunter behaves like a hacker simulation tool that probes your Kubernetes cluster to find weak points. Unlike audit tools, it is active and offensive in nature. Why KubeHunter is used? It helps you detect exposed Kubernetes components, identify misconfigurations, find attack surfaces before attackers do, strengthen cluster security posture, validate production readiness. What KubeHunter checks: 1. API server exposure, open Kubernetes API endpoints, anonymous access enabled. 2. Node vulnerabilities, open kubelet ports, unprotected dashboards. 3. Misconfigurations, weak RBAC rules, privileged containers, insecure et access. 4. Network exposure, services exposed publicly, insecure ingress setups. How KubeHunter works: KubeHunter scans network plus cluster endpoints, performs security probes, reports vulnerabilities. It behaves like an attacker, sends requests to Kubernetes APIs, tries to access sensitive endpoints, detects insecure configurations. Modes of operation: 1. Remote mode runs from outside the cluster, scans public IPs or endpoints. 2. Pod mode runs inside the cluster as a pod, finds internal vulnerabilities. 3. Interface mode, interactive CLI scanning tool. Example output: high API server allows anonymous requests. Medium Kubelet port 10250 is publicly accessible LOW. Dashboard is exposed without authentication. KubeHunter vs KubeBench feature. KubeHunter KubeBench type active penetration testing configuration audit approach simulates attacks, checks CIS compliance goal, find vulnerabilities, ensure best practices style, offensive defensive output, attack surface report, compliance report. Simple analogy, think of Kubernetes cluster equals building, KubeBench equals safety inspector checking building codes, KubeHunter equals ethical hacker trying to break into the building, benefits identifies real attack paths, helps improve security posture, detects misconfigurations missed by audits, useful for penetration testing, works in CI or CD security pipelines, limitations can generate false positives, requires security expertise to interpret results, does not automatically fix issues, may be intrusive if run in production without caution, best practices run in staging environments first, combine with KubeBench for full coverage, fix high severity findings immediately, restrict API exposure before running, use as part of DevSecOps pipeline, real-world use cases, Kubernetes penetration testing, security assessments before production deployment, compliance validation, cloud security audits, red team exercises, interview ready. Definition: KubeHunter is an open-source Kubernetes security testing tool that actively scans a cluster by simulating attacker behavior to identify vulnerabilities, misconfigurations, and exposed services, helping organizations discover and fix security risks in their Kubernetes environments. Great, moving on. That wraps up this episode. Nice work practicing, and see you in the next one.